Okay, we're going to write the rule for the nth term in a geometric sequence or series. And you can start by writing this down. This is the rule for the nth term in a geometric series. I'll remind you that this guy right here, a sub n, is referred to as the nth term. And we can figure out what any particular term in a geometric sequence or series is using this formula. Again, I'll remind you a sub 1 is something that we knew from arithmetic sequences and series. It's the first term. In fact, we knew it even before we knew what an arithmetic sequence or series was. It's a sub 1. It's always going to be the first term. And then this r is the common ratio between terms. That's what r is. And we only have a common ratio between terms when we have a geometric sequence or series. And then n is the particular term that we're at in the sequence or the series. And I'll remind you about that. It goes like this. We say n equals 1, 2, 3, 4. It's the index or the number of the term in the sequence or series. These guys up here are a sub n. In other words, a sub 1, a sub 2, a sub 3, and a sub 4. Okay, now let's go ahead and actually write the rule for this particular geometric sequence using this formula. The good news is this is pretty straightforward. See, it's really easy to find a sub 1. It's just the first term. That's what this guy is right here. It's the first term. So we'll go ahead and write a sub 1 equals 3 in this particular sequence. And then we really should check to see whether it's a geometric sequence before we say what r is, but let's take a look. R should be the second term divided by the first, in this case 15 divided by 3, which gets us 5. And just to make sure that it's a common ratio and not just the ratio of the first two terms, 75 divided by 15, that's 5 also. Okay, I'm getting a warm fuzzy feeling that maybe there's a common ratio and this is a geometric sequence. All right, now that we have those things, we can go ahead and say a sub n must be equal to 3 times 5 raised to the power of n minus 1. Now, those of you that are particularly astute, you might say to yourself, aha, I'll bet you can simplify this by multiplying the 3 times the 5. Please do not do that. PEMDAS always says apply this exponent to this base before you ever do anything with this. So if you go to evaluate an expression and you have something like 3 times 5 to the power of, I don't care, let's say 4 minus 1, that is not equal to 15 to the power of 4 minus 1. I recommend that you try doing this part first and then multiplying times 3 and then try 15 to the power of 4 minus 1 and just see if they're equal so that you can say for yourself, yeah, I agree. In the meantime, let's box our accomplishment here. This is what we were trying to do, and I only told you this to try to keep you out of trouble in the future. Now, one last little thing that we'll do is we're going to try to use this sequence to figure out what the 9th term is. So let's take a look. We'd like to know a sub 9, which is also known as the 9th term, and the way we'll find it is using this rule right here. A sub 9 for this particular sequence will be 3 times 5 raised to the power of 9 minus 1. So that's not so bad, although we got to do a little bit of math. That'll be a sub 9 equals 3 times 5 to the power of 8, and whatever that is, and that's going to be a pretty big number. So let's take a look and see what we can do. Okay, according to my handy dandy calculator, if I take 5 and raise it to the power of 8, I will get this big number. So we'll do 3 times that. 625, and then we'll do 3 times that, and that'll get us the result. So it's a big number, And let's go ahead and get that down. And that turns out to be 1,171,875. That's a sub 9 for this particular geometric sequence. Now, one of the things I want to point out is that's a really big number. And that was, we only went to the 9th term to get it. That's kind of the nature of geometric sequences and series, is that they get large very quickly, much more so than an arithmetic sequence or series. All right, that's what I got for you on this one.